Hey, what's up? It's Zane Khan from Chem 1412 for Professor Fox. Today we're going to be doing experiment or lab number 8, which is determining the K of calcium hydroxide. Chem 1412, section number 62430. So let's go ahead and dive into the experiment. So as I always like to say, before you do any experiment, it's always good to look at the reason, the background, and the overview of why you're doing the experiment. Not only does it help when you're doing the experiment, but it also just, it's good to know stuff. So pretty much in this experiment, we will be determining the solubility product of calcium hydroxide, which is right here. It's obviously, as you can hear, it's solid. It's slightly soluble in water, and by titrating a sample of calcium hydroxide with an acid, we're going to be able to do that. And we're going to be able to determine the new solution. So a little bit of background is solubility, or the degree to which they dissociate in different solvents. Many chemicals have some measurable solubility in a solvent. The general classifications of solubility are insoluble, slightly soluble, or soluble. Insoluble compounds obviously have a concentration of less than 0.01 moles per liter, and slightly soluble compounds have a molarity of between 0.01 all the way to 0.1 moles per liter, and whereas soluble materials have anything that's greater than 0.1 moles per liter. So yeah, we have those. We have insoluble, slightly soluble, and soluble. So solubility is also determined by the application of an equilibrium equation. Typically, an equilibrium equation is used to determine the equilibrium constant. So there's a whole formula where you do K equals A to the power of W times B to the power of X, for example, and then you go ahead and you plug everything in. And KSP is also known as a solubility product, which is the product of the concentrations of the ions from a parent molecule. So yeah, we also got the molar solubility. Just refers to the number of moles of a molecule that will dissolve in 1 liter of solution. The equivalence points, I've talked about this in previous lab videos. Equivalence point of a titration is the point at which the moles of acid are exactly or equal exactly numbers of moles in the base, in the moles of the base of solution. When they're both equal, that's when you have an equivalence point. And there's also something called the endpoint. That's the experimental estimate of the equivalence point. In this investigation, the endpoint is identified by a color change in the indicator solution, methyl orange. So yeah, it looks like a very interesting experiment. Let's go ahead and jump into it. So before we start the experiment, it's always good to label, or not label, just to make sure, lay everything out and make sure you have all the needed stuff. So let's go ahead. We have the 1 ml syringe right here. We have the lime water right here. Yeah, lime water right here. Calcium chloride, hydrochloric acid, hydrochloric acid, 25 ml Erlenmeyer flask. We got the electric balance, disposable pipettes. We got multiple of them just in case. And we have a clean sheet of white paper to record all of our data and whatnot. And we also have water and bottled water right here. So let's go ahead. We also have the methyl orange indicator. I have to point that out, but it's right here. Okay. So before we start any experiment, it's always also important to make sure you got your apron on, you got your gloves on, you also got your goggles on. So you want to make sure before anything, your safety is always the first priority, top priority. We're dealing with hydrochloric acid and calcium hydroxide, which are very corrosive chemicals. Gotta be mindful of those things. And yeah, let's go ahead. So first thing we're gonna do is place the 25 ml on the flask, on the balance, 25 ml on the balance. Turn this on, and we're gonna record the mass. can write down my laptop. Next, we're going to measure 3 ml of lime water with the 10 ml graduated cylinder. 3 ml of lime water, 10 ml graduated cylinder. And since this is a titration experiment, it's always very important to make sure you have precise, or you can have precise measurements, and to make sure you're doing that. So, got 3 ml of the lime water, and then pour the lime water into the flask. Okay, and record the exact mass of the flask. So, like that. So we got 2.88. Okay, so I'm gonna go ahead and record the exact mass. Add 5 drops of the methyl. I'm gonna add the 5 drops of the methyl orange. I'm gonna go ahead and finish the experiment, and I will let you know how it goes. 2, 3, 4, 5. Okay. We'll see you then. Bye. Thank you.